really interesting. And if you see this project, you can appreciate what ChatGPT does. But I think it's interesting to look at our project too, the traditional way. Yeah.
Yeah. And then, yeah, this is talking about like what technologies we use. So the main plan was to use the Google Cloud as much as we can because we wanted to have more exposure on the Google Cloud. So for the front end, there's a service for the Google Cloud called Dialogflow. So using that service, it acts as a front end for you, and then you can have like intents, entities inside that. We'll talk about it in detail when we go to the front end section. Then for the back end, we use the cloud, Google Cloud's cloud functions. So it has like different triggers. You can set it up by HTTPS, Cloud PubSub, or whatever you want to use it for. And then for the database, as Yufei mentioned, we went for the standard approach. So standard SQL that is provided by Google Cloud's BigQuery. So that was our tech stack, I would say. And then this is like the architecture, like overall architecture, how it looks. So user interacts with the Dialogflow. Then Dialogflow, like based on the interaction with Dialogflow, it detects an intent. So based on the intent, it decides that do I have a pre-existing response for this? If it does, then it sends that response. If it does not, then it processes that request. It goes to the cloud function using webhook. Then it processes the request from the Dialogflow. It forms that, it selects the accurate SQL query. It connects to the BigQuery, and then it comes back to the cloud function, and then we format the response back to Dialogflow, which gives it back to the user. So it's like an entire circle, and basically using three technologies, but having like layers and stuff on top of that just to process it better. So this is like the overall architecture, and talk in deep about it. So we have Dialogflow, as I mentioned. So it has user inputs, it has intent recognition, it has entities. So intent recognition is a pretty good feature of Dialogflow. I'd say that based on you can provide it training phrases. So let's say that if you have some specific requirements for any of your project, or you are building a chatbot or any interactive tool, so it can have that feature that it could recognize intent, and based on that you could also provide it like as a variable. So let's say that if someone is asking for a specific book, you can based on the response provided by the user, you can record that and pass it as a variable in your code. So that is a really good feature that which we try to use. We have webhook triggers, and then after we get the webhook, it goes back to the cloud function, and that's where the process happens. So this is all about the Dialogflow. Then yeah, this is how our UI looks. So we try to make it similar to the library. So like if you guys remember the library website, so this is closely related to that. So we try to match the theme. So we don't have like an interactive, like it is interactive, but we don't have like an full website. It's just a chatbot. So we just try to create the chatbot and show its functionality, like how it's going to work. So this is how it looks. We of course will see it more live working in the demo. And then talking about the backend. So yeah, once we get the intents from the cloud function, what we did in the backend was based on the intent we get from the user, corresponding SQL query is going to run in the backend, what cloud function runs. And based on that, we'll get the responses from the BigQuery. So we have a database which is full of, I would say, FAQ questions and answers. So based on the intent provided by user, cloud function, we have written the code which identifies the intent and then runs the corresponding SQL query, and then gives the response back. So that is our main backend, which actually works in this way. And we have also tried to format it in a JSON structure so that it could give the response back to Dialogflow, where you can see the results, final results. And then moving on, we have DB design and
yeah. So basically, first we scrape the websites. So we look at 5 or 6 websites, and we don't want to scrape them illegally. We want to scrape them legally. So we found that the library FAQ page, they provide this structure for us to get the questions and answers. And after that, we get these Q&As, and we put them into our database in BigQuery. And after that, we extract keywords, the traditional way of doing things, using a TF IDF vectorizer. And this could be replaced by embedding through Gemini or ChatGPT stuff. That's probably for the future of this project. And I did the project by the way, with something called a werewolf using GPT-4, and my credit card is burning, so we have constraint on the budget, so we use the traditional way. But I think it would be very interesting if we use these AI infrastructure for the future, and the answers will be much more, I would say, accurate, human-like. And by the way, ours is very accurate, but it's just a replication of answers from library, but it's too long sometimes. But yeah, we can probably go to demo, right?
Yeah, for sure. And the next we have demo, so open that. Yeah, so basically, like, okay, let me minimize it so everyone can see. Probably. Yeah, so this is our chatbot. Like, as you can see, like this is similar to close to like the library website what we were planning to. So once you click on that, it will open, and then we can start with something. Let's say hello, and then it gives the back from the welcome intent, and then you can ask like I need help or something like that, and then it's going to ask like do you need some specific service or specific help do you need with. So I can say let's say that I need information on printing or something similar to that. So I need to know what all printing services is provided by the library. So if I just type printing, then it's going to give us the response for the printing.
It's cool.
Yeah. You have done that right.
Do I have credits left for the
I think so.
Pull out my credit card.
Yeah. So
it's here. Okay.
Yeah. So yeah, all print you get the response. All printing in the library uses the Print Smart system and as student faculty. So these are the responses by the library FAQ sites when you ask.
By the way, you can see some links right here.
Yeah, you can see the links as well. So the thing I mentioned, right, you can go to this specific link. So it provides all the responses for that. So for like how do you want like whatever you want to print or how you can print and how you can use the funds and whatever the leftover. So we try to provide like a detailed response so that user can get all the information you can in one prompt and not keep on writing prompts until it gets something correct, something not. So we just try to get all these corresponding answers that matches the keyword print, and then it shows you all the results all together. So you are able to get the response from that. So we have another as well. So like if you want all the library related questions, so if I just type library help or how do I borrow a book or something like that. So I'll show you the dialog flow as well, so it could help you get more idea. So if we go to intents, right? So these are all the intents. So the one response we got was for the printing intent, right? So we asked something related to printing and it detected this, and then we got the answers from the printing. Similarly, let's say that if you want to select something else like database or digitization, equipment, library help. So let's say book return, right? So I just asked about book return, and probably it should run the responses. Yeah. So it also gave us the same some questions, but of course, as I said, that it matches the keyword. So if it is inside the book return as well, so it's going to process it and then provide the response. So that's what we have. This is something we developed over the year. I'd say there's so much room for improvement. We know that, but this is what we could achieve so far. And yeah, that's pretty much it.
Just to add on, I think the good part is that it's 100% accurate from the library. If there are any information that's wrong, you can blame the library.
Library itself.
There's no hallucination from ChatGPT, but it's a long sort of answer, and probably the improvement, like Dharmik said, is to sort of truncate and use embedding all these kind of AI stuff to improve the answer so that the user can actually read and get the information very quickly. So.
And we actually, I tried to reach out to one of the staff who manages the library website, and they said that this is something they could use, because if you go to the library website right now, there's only one option, like ask a librarian. There's no bot or something like that. So they are happy to provide us more information if there is someone who's willing to work on this longer time and develop it properly so that they can implement. So
and steal their job.
Yeah. But that's what we have. Yeah.
Do you just want to quickly, I guess, show your face?
Sure. What are the next?
Oh,
I can go next.
I'm just wanting to talk about those right now.
Oh, is it going to take time?
No, it's good. It's just a second.
Okay, then I can. Yeah.
How about we switch to the we can share?
I think it's okay because I'm just gonna be a little bit off the side.
Oh, but
think
you'll
I'll
be
be
sharing on here.
Yeah, I think it should be fine. Does it show up? Okay. It's fine. Okay.
Do you want to see it?
Oh, okay. That's fine. Hi, everyone. I'm Zareen. I was the lead for the Gamified Learning Platform project. So we'll start off with some introductions. So we had about 13 or 14-ish people on our team, some of whom are here in this room. We had Alex, Aaron, Angad, Clara, Enes, Eric, Harvin, Mithun, Rachel, Sky, and Zane. These were all the people who worked on many different parts of the project. We didn't really have defined roles in our team, so we kind of had everyone working on a little bit of everything, both front-end, back-end databases, and so on and so forth. So I wanted to kind of indicate some of their highlights, but I think everything that they worked on were highlights. But yeah, let's dive into what the purpose and the impact of our project is. So our gamified learning platform was built to help improve the current structure and landscape that this education world and the middle, high school, and like undergrad world is experiencing, where there's a lot of information coming in, but it's hard for students to process and understand a lot of the tools and techniques that they're learning in the classroom. This causes a lot of students to become unengaged. It causes an overload of content, and educators are also constrained on what they can teach and how they can teach it. This is where our platform comes in, where we're determined to better engage students through dynamic learning modules. We want to help them learn better through engaging in games and quizzes, and we want to help teachers be able to customize those quizzes, as well as helping improve the learning outcomes and development of the students through gamification. Throughout the last 2 semesters, we went through certain steps throughout our development process, where we went from planning to deployment. Our first process was in the conceptualization and planning stage, where we had set up some initial goals to have a minimum viable product, where we would build 5 main pages. We used an agile structure to have biweekly sprints, where we went through sprint planning and a retrospective beginning at the end, so we can make sure that everyone was developing at the same rate and was on the same page throughout the process. Our platform has 4 core features, where we have the user authentication, the registration and login pages, the dashboard, where students would be able to try out different quizzes, look through their progress, and look at what's coming up next, the educational modules and quizzes, where they would be able to look through interesting lessons that their teachers posted, as well as work through some fun quizzes, as well as a leaderboard system, where students would be able to see where they rank based on their scores throughout the quizzes. So we used a lot of different technologies, some of them more than others. Our main backend was developed on Python and Flask, where we set up many different endpoints for each of the pages, as well as to make sure that everything was dynamic and easy to access. This is also a fairly easy development language, so if you're planning to get started, Flask is the best way to start up on the back end. Our front end was based on HTML, CSS, and JavaScript. A lot of HTML and CSS, less so JavaScript. Our database locally was based on SQL Alchemy. This is a very simple derivative of MySQL. So yeah, and we also made sure to have continuous testing throughout the process through creating unit tests through PyTest for our backend and Selenium for our frontend. We also developed some GitHub actions to make sure that each PR and commit was being verified to pass all of the current tests. And at the end, we containerized our application and deployed it on App Engine on Google Cloud Platform, and our database there was Cloud SQL. So throughout the process, even though we had a goal to have 5 main pages, we did go a little bit further beyond our initial objective, where we were able to develop a role-based access system where teachers would be able to gain access and modify different quiz structures. We also set up a feedback system for users to send back information on what they thought of something or if they had any questions on how to use things. And we also made sure that our pages were dynamic and we had accessible endpoints. So I'll be going through the demo. We did deploy it, so if you're interested, you can scan the QR code to take a look. You can also do it after, but yeah, I'll start up. So our main page looks like this. So when you first click our application, I hope it works. Okay, you'll be welcomed into our main page where you can kind of learn a little bit on what this platform is about, and you can also get started through here. So our 2 main options are, if you're a student, you can fill in the student section to register, or you can fill in the teacher section where you get a little bit information on the teacher. So yeah, I think I'm just going to skip the login because I've limited time, the registration, and just go into login. So I just filled out my information and logged in, where you'll be shown the main dashboard page. So here you can look at what current units you're done, if you have any daily challenges, if you want to test yourself through some fun quizzes, and where you face on the leaderboard. As you can see, I'm not that high up on the leaderboard. Let's start off with a lesson maybe. So we just have a simple structure right now. If teachers want to add in more features, they can add in topics here, add in more lessons, add in more modules, so on and so forth. So we can look at a lesson where you can, this is just like, I guess, basic gibberish, but yeah, you can add in actual content here and click on any of these, add in your textbooks, PDFs, practice and familiarize yourself through any question modules. We'll go through one of these. So here you can even click on video link directed right to this video by Khan Academy, but you can add in any video that you would like. If you go into a quiz, this is just a simple layout. This can be modified and like made more complex in the future, but I can go through a simple quiz like this. I actually don't know the answers. We'll just work through it and submit, where you will be led through a score page. Going back into the dashboard, we can also take a look at the leaderboard page, where students are ranked based on what they're doing. And one of our future objectives was to set up a cash-in page. So if you get up to a certain point, you can try and purchase anything that your teacher can set up as like a reward system. I'm going to quickly sign out, and we can take a look at the registration page. So I'll sign in through here. And the system will automatically identify if you're a student or a teacher based on how you initially registered. This was set up in our backend. But yeah, you can look at any courses that you currently have. You can change courses, switch them. You can look at your current class list, look at how the class is progressing so far. And you can also add in information on notification. Any of these can be swapped out or changed. We also have our contact page, which is not here. It's here where you can email us, know about any frequently asked questions. And yeah, that is the basic of our application. Going a little bit into the code, we tried to make sure that we split up our code into easy to understand sections. So much of our database and structures for our infrastructure is set up here, where you can take a look at the models and learn a little bit on what each of them do. My team, I was really grateful, was really good at commenting and making sure like they explain what everything does. So there's a lot of, I guess, comment messages. Our authentication system is set up through app routes. All of our application is like endpoints are set up through app routes like this. And yeah, this is just an example. Our Dockerization was done through Dockerfile. Because we deployed it, we set up our deployment. We set up our Dockerfile inside the deployment, so it's easy to access. But yes, yeah, we'll just go back. Yes, you can try and take a look. Maybe I can bring up the console just to show what the application looks like. So we didn't do as much in terms of our deployment. I know like we could have gone a little bit further in terms of setting up load balancers, but we just have our simple App Engine application set up, as well as our SQL, Cloud SQL, which is based on MySQL. Yeah, and you can take a look at, I guess, how much traffic we're getting. I guess we're getting a spike now because people here are scanning and taking a look. Yeah. So moving on to our project outcomes, we kind of had two main goals for this project. One of which was a functional goal, where we wanted our application to have most of the major features and have the minimal viable product that we wanted to access. And we also wanted this to be deployed and accessible by anyone who wants to take a look at it. And also, we wanted our team members to be able to gain valuable skills in their software development journey, learn a little bit more about how to work with different applications, how to work in a team, and learn to communicate. And I think at the end of the semester, we can kind of say we successfully achieved both of them. Everyone on the team was able to work on something that they never had experience on, and our application is mostly functional. I will warn you, if you do click on it, there is some areas that are a little bit under construction, but yeah, the applications should mostly work. So in terms of future roadmaps, there was other things that we could have done to improve. There could have been areas on making things a little bit more dynamic, having more custom algorithms or data structures set up. But I think because it's at the end of the semester, we will be opening up the project to our community. If any parts of the project is interesting to you, if you want to implement anything to it, feel free to contribute. And yeah, I'll keep maintaining it. I think the other leads, if they have some free time, would also like to maintain some parts of the project. So yes. In terms of final acknowledgements, I do want to acknowledge everyone on the team who worked so hard and worked long hours to make sure that we had a good product at the end of the day. I also want to thank my leads and Ron, especially, who helped to set up a lot of the GitHub Action stuff, and as well as the GDSC team and Ishita, who helped us go through this application. Thank you for listening. Here are some of our links. I wish I could have a good project link, but it's just going to look a little bit ugly for now until we can set up a good port forwarding DNS system and join our Discord. Yes, that's it from me. And if you have any questions, feel free to, yeah. Okay. Moving on to Ron.
All right, so my name is Rowan. I'm one of the open source leads, and I was responsible for leading the Automate project, and on my team we have today Raymond, Austin, Mohammed, Nicole, and Laik, and a few other members that weren't able to join us. But I'll be passing over to Austin to talk about the project scope and kind of the motivation behind Automate.
Yeah, so just to get into kind of the background about the whole project itself, it was all about trying to develop a machine learning platform that was easily accessible. But to kind of give a background on what kind of traditional machine learning workflows look like, we start with kind of defining a problem, collecting data, and then going through the tedious process of processing this, and then finding the resources to train it, and then lastly, figuring out how we evaluate this. But our project aims to kind of simplify all these things and kind of just have the user define a problem, give it data, and the platform will abstract all this itself. And to kind of go into the workflow of our Automate itself, the user can provide the platform with data, and they can upload or select pre-existing data models or model. And the platform itself will provide the data analytics and the final machine learning model itself.
So now a little bit about the tech stack and the software design and kind of how we approached it. So we split up our front end and our back end. We mainly did it to make it easier to isolate in the deployment architecture. So we could do each kind of task could do its own thing and then bring those parts together and display it. So for the front end, we worked with React, Next, follow JavaScript, and then Material UI helped us keep like the style consistent with all the symbols. For our backend, we use Pandas profiling for the auto EDA. For query, we use the BigQuery and Google SDK. And then for our AutoML, we use a lot of cool functions from PyCare to make plots and graphs. So as you can see, we heavily relied on like a lot of open source libraries to bring all these parts together. And that really like helped us to avoid like all the like heavy logic we have to go through to implement like the AutoML and the Auto EDA from scratch. So it made it a lot easier, and there's a lot of like documentation. So just kind of more of an enjoyable process implementing these cool parts of our project.
So this is our project structure. When we started off, we knew that we need to use like different accounts to use up like credits, and so we realized we like should use like infrastructure as code tool. So we decided to go with Terraform. Basically, our Terraform file just sets up our Kubernetes engine, like the node pools and the pods, and it also sets up our bucket into the project in general. So it does the configuration. When we create a new account, we don't have to like go in and manually add these things, which is like an area where you could like make an error, forget something by accident, and that will cause problems down the line. If you look at our architecture, we also use Google Cloud Storage. So this is where we store our data sets, and we also put our images in there that you'll see in the demo. And we also have BigQuery for creating our data sets. We also see that in the demo. We also decided to use like Docker images for our project in Kubernetes engine. Because, like as Nicole said, we already had our backend and front end decoupled. It's really easy to do that. And also for a product kind of like ours, we have different services, and it's easier just to add like a new service, like a new machine learning thing, as its own thing. And we want it to be easier to add these things like throughout time. So Kubernetes engine allows us to do this. We have to Dockerize our images, like our product, and then just put it in there, and it just works.
Okay, so
Wait, sorry. We're just gonna quickly look at our what we got going on our cloud. So I don't know if it shows up on the video, but I'm just gonna quickly scroll through. So on our Kubernetes engine, we have our deployment up with our set number of nodes. And then we have our workloads up. So we have our backend workload and our front end workload up. And I think the other services we used were buckets. So as Mohammed mentioned, we did a lot of work with like temporary storage on our application. So in order to store the user's data sets and the plots that were coming out of the models, as well as the models themselves, we used temporary storage on Google Cloud. And just to quickly show what we were talking about with our GitHub, this is our Terraform file. So it was really nice, as he mentioned, to have our code for the Google Cloud architecture to be something programmatic that we can consistently reuse. So as we mentioned, we're running on free credit that expires in 6 months. So every couple of months we would have to like switch over our accounts, and so it made it easy to rerun our infrastructure. We would just run a few actions that Laik will be talking about in a moment. But yeah, so our entire architecture was defined programmatically, so we wouldn't have to be going back on console or going through the CLI to try and redeploy everything. Okay, I'm gonna stay on the GitHub, and then Laik can talk about the pipelines that we have.
Cool. Okay. So to set up the infrastructure, we basically have 3 action workflows. The first one is manually deploying the Terraform file we have and applying the changes. The main thing which it does is it creates a new bucket in the cloud storage, and it also sets up our machine learning and front end and back end node pools where our clusters and pods are running. So once that is done, we deploy our images using the Docker workflow, and we need to build the front end and the back end Docker images. We also have the ML image, but I don't think we are working on it right now. So these images are being built locally and being used using Docker Compose for local production. But once we want to deploy to the cloud, we push it to the artifact registry on Google Cloud, where it gets compressed and gets pushed to the clusters which are going to use them. And the last step is the Kubernetes.yml file, which is basically going to take those new images and make new pods and apply those changes to the running containers. And if the containers do not exist, it's going to create them. So this is like the meat of the application, where it takes everything which has been built before and pushes it to the actual running units, which are the containers and the pods. And once that is done, we have our application running and accessible to external links on the Kubernetes engine. And yeah, that's pretty much it.
Yeah. So if anybody's interested in taking a look at how we set up our actions, they're all in this folder. And it basically makes it really easy for us to transition our development code into cloud infrastructure really quickly just through running a few actions. We also had them set up as like pull request based, so that was also kind of nice, but we wanted a bit more control because sometimes our pull requests would like make things fail. So we set them up to be like action triggers, so you can go through and run a workflow manually, or you can have it set up be where like every single time somebody makes an update to the backend folder or the front end folder, the Docker image gets pushed to our artifact registry right away, and then the application refreshes completely. So it takes off like all the work from us trying to rerun the application. So I believe next is our demo. So we do have it working on Google Cloud, but there are a few hiccups, like our logo not showing up. But so we're gonna show it locally. Fingers crossed, everything works. So this is our homepage. The click-through starts at this button, but we also have our how to use model and our about us pages, but we'll go into those in a second.
Can you zoom in?
Zoom in. Yes, sure. I can zoom in. Okay, so the first page you're met with is the upload your dataset. So you can upload your own, or you can select one that's on our Google Cloud. So I'm going to select one on fish species. So for context, this is kind of the dataset that you use to train your machine learning model on. So you can come with a data set yourself, or you can pick one from a variety. And then it gives you some information about the data set. So this is just the head of the data set, a few entries in it. And then next it runs the exploratory data analysis. So as we mentioned, this is something that's been offloaded from us. We didn't write the code ourselves to do the EDA, just because it takes a lot of work to do this kind of data analysis from scratch. We used a library called Pandas Profiling to do all of this, and it gives you all the correlations for the data set. It gives you things like missing values, interactions, all the variable names and whatnot. And just like a lot of information that a machine learning developer would use to assess their data set, make sure that it's clean, make sure that there aren't major skews and whatnot. So yeah, this kind of takes that work off of the data scientist, and it just gives you like a nice clean profiling report for your data set, and you can assess it for whether or not it's useful for machine learning or not. And then our next page was kind of something that we added in just for fun. It's a query page. So if you're a developer and you're interested in seeing certain properties of your data set, you can run your own queries. So we have this going on right now. You can like run counts on species, things like that, and it just returns the output of the SQL query. And then finally, we have the AutoML itself. So this is what will generate the model for you. And so this is like the main component of the application where you're able to select the type of machine learning task. So we limited ourselves to classification and regression. And then you can select your target column, which is basically the column that you're forming predictions on, which is like the thing that you want to predict. So for this fish species data set, we want to predict the type of species based on the attributes of the fish. So if we click Start AutoML, it takes a little bit of a minute because if you guys are familiar with it, machine learning kind of takes a long time with the regression that it runs on the values. And this one even takes longer because it does an architecture search. So it's training a bunch of different models and then trying to pick the best one. But yeah, it returns a scoring grid for you and a plot that shows your accuracy charts. So this is basically all the models that were trained, and it gives you their accuracy and a few other metrics that are helpful for machine learning engineers. And then you can download your favorite model or your best model that performed the best. And so that's basically the entire application, like all the steps that you take in order to obtain your model. And then how to use your model. So you downloaded a model, you have this like the file in your downloads folder, you don't really know what you're gonna do with it. The idea is you can import it into basically anything that supports pickle files. So Python has a few libraries that do support pickle files, and basically a pickle is a serialized version of the model. So here we used PyCaret. This is just a Jupyter notebook. So I ran it locally where I had the model saved in my Google Drive, and I was able to load the model and then load the data set that it was trained on and then gain some predictions on it. So here at the bottom, you can see you've got like the accuracy score. So it's 97% accurate. And basically the idea is once you're at this stage, you can embed the model into any application you want and start using it for whatever application you have. And I think that covers it. We just got like the About Us page and the GitHub page if you guys are interested in checking it out. But yeah, any questions, comments? You can take them now.
Okay. Thank you for joining us. We'll just end the stream here, and there'll just be discussion section. Yeah. If you want to come talk to us, we're in H324.
Is there anybody?